right, welcome to Stoichiometry problems number 3. And if you do not have a calculator and a periodic table out in front of you, I do suggest you get that. You might want a polyatomic ion sheet for one of the thinkers on the back, just so you know. Get my calculations out here and we'll get started. All right, so the question is we have two understandings of the mole. We know that we have moles of a pure solid, liquid, or gas is equal to mass over formula weight. We know that mass is measured in grams, and formula weight you can always find if you know the formula and you have a periodic table. Moles of a solution, on the other hand, takes its molarity, or another word for concentration, times volume, making sure that volume's in liters. So again, as we watch this, I would go through and pause the program, and whenever you can, do your own work. But if you need me to help you get started, then pause it, go ahead. So the first question said, which has more molecules of salt? 27.9 grams of solid salt or 32.4 milliliters of a 3 molar salt solution. So to figure out which one has more molecules, we're going to put each one into moles. So once we do that, we know that this is a solid NaCl. So I can't use this. I'm going to use this for the first one. And I'm going to use the second equation for the second one. Be very careful of this unit. So again, pause the program, try it yourself. If I take my 27.9 and I divide it by the formula weight of NaCl, that's going to be 23 and 35 gives me 58. When I divide that, I get 0.48 moles of salt. Now over here, we're going to take our molarity, which is 3, and we're going to multiply it by, we got to move this 1, 2, 3, 0.0324, and you end up getting only 0.097 moles of NaCl. So the winner here is the solid. Definitely have more salt in that situation. Number 2, remember when you come up to any equation, you want to make sure it's balanced, and then take a look and try to answer the question. All right, so it is balanced, and we look like we're looking at two solutions here. You can see I have 10 milliliters of a hydrochloric acid solution, and I'm neutralizing it with some sodium hydroxide solution, and I'd like to know the molarity. So what we want to do is we want to make sure that we are using moles is equal to molarity times volume in liters. So I know my hydrochloric acid, okay, I know I have 0.01 liters because I moved this decimal, and it's 1.25 molar. I want to know the molarity, and I have the volume of the NaOH. So take a look at this problem and see what you know the most about and which one you can put into moles. All right, so the first thing we can do is if we have moles of HCl, we're going to do the molarity, which is 1.25 times my volume in liters, and that's going to get you 0.0125 moles of HCl. Second thing you always do in a stoichiometry problem is you check the mole ratio. This happens to be a 1-to-1 ratio, so that's also how many moles of NaOH we have. Now, the question doesn't want moles of NaOH, it wants to know what's the molarity of NaOH. And we know that moles are equal to molarity times volume in liters, so I'm going to bring down the m and have that hold my spot as my variable, and I'm going to multiply that by our volume in liters, which is 0.0963. Now, how do I solve and leave m by itself? I'm going to divide this by 0.0963 to get m by itself. Divide this by 0.0963. And when you do that, you get 0.13 molar, got to have the m for the unit, NaOH. Take a look at number 3. Make sure it's balanced and see if you can't pause the program and do it yourself. All right, so for number 3, it is balanced. You can see you have got to read inside here of the data table. I have a 0.1 molar KOH. I also have measured out 0.0249 liters of that acid. Oh, I'm sorry, that's the base. And then I would like to know the molarity of the HNO3, and I've measured out 0.01158 liters of that. We know these are both solutions, so we're going to use moles equal molarity times volume in liters. Which one do you know the most about? Good, the KOH. So we can get moles of KOH is equal to the molarity of KOH, which is 0.1, times the volume in liters. When you multiply that you get 0.025 moles of KOH. Next, we're going to check our coefficient ratio. We're going from here to here. This is a 1-to-1 coefficient ratio, so that's also how many moles of HNO3 we have. Again, we're looking for the molarity. We have moles, we have volume, so I'm going to say M is equal to, and then I'm going to plug my volume in, and then how do we solve for this? Divide to get M by itself by 0.01158. Gets M on itself by 0.01158. When you do that, you end up getting 0.22 molar HNO3. All right, so let's take a look at number 4. I would take a look at the problem. It's going to be a little bit different than the problems we've been doing so far. Might have to think back to a different formula, one of the ones that we wrote at the top. Balance it and see if you can answer this. All right, so to balance, all we have to do is we have to put a 2 here and a 2 here. And then the question says, what mass of calcium metal? So I want to know calcium metal is needed to react with 11.2 grams of O2. So I don't see anything about molarity. I don't see anything about liters. So I'm going to have to go back to our first formula, which is moles equal mass over formula weight. So get out your periodic table. I can find moles of O2. As soon as you do any Stoich problem, the first thing you're going to do is figure out what you can get moles of. So I'm going to take 11.52 and divide by the formula weight of 16 and 16 gives me 32. When you divide that, okay, you get 0.36 moles of O2. And then we got to follow our coefficient ratio. I'm going to be very careful. This one's a little tricky. We're going from here to here. We're going from a 1 to 2. 1 to 2 ratio. So I'm getting bigger, so I'm going to double my moles. When I look at that, I look at 0.72 moles of calcium. Now, it didn't ask how many moles of calcium. The question said how many grams of calcium. I know moles equal mass over formula weight, so I'm looking for mass. Formula weight of calcium is 40. We're looking at 28.8 grams of calcium. Now, question B, or set B, okay, if you can do it, pause the program. How many grams of CaO are going to be made from the same amount of oxygen? So what I'm going to do is I'm just going to pull down the exact same number of moles. I could divide this by 32 again, but I'm just going to say, pulling down the moles here, 0.36 moles of O2. Now I'm going from here, though, to here. So our coefficient ratio is still a 1 to 2. So I'm going to double this again. 0.72 moles of CaO, but now I want to know how many grams of CaO. Put it over the X of 1 calcium at 40 and 1 oxygen at 16 is 56. And the answer is 40.32 grams of calcium oxide. Now, I'd say C is a little bit of a thinker. Give it a pause. See if you can't figure out how to answer this. If the student dissolves all of the CaO, take all of it, and I can assume 100% yield in the total final volume of 200 milliliters of water, what would the molarity be? Now remember, we can change our equation that we've been using and change it to molarity is moles per volume in liters. Okay, so I have that number already. If you want to redo it, you can. However, you'll see I made 0.72 moles of CaO. So I can just bring that down. So I'm going to put 0.72 moles of CaO. And the volume in liters, this is not liters, so we're going to move it 1, 2, 3. Move this, 0.2 liters. And when you divide that, you get 3.6 molar CaO. All right, flip it over on the back, see if you can't knock out a few of these. Balance it first. All right, so to balance this, we're going to stick a 2 right here, and we're going to stick a 2 right there. Consider the following chemical reaction. You have 35.62 milliliters, I'm going to change that to liters, of H2SO4. It is neutralized with 47.60 milliliters of a 0.5 molar NaOH. What mass of pure water will be produced? So they're trying to give you a distractor here, I think. We're looking for mass of this bad boy. You see you have some information about the sulfuric acid, but hopefully you didn't get tripped up on that. What I'm worried about is my NaOH, because I always got to find moles. So moles of NaOH, or the only thing I can get moles of, is equal to the molarity, which is 0.5, times the volume in liters, which is 0.0476. When you multiply that, you put 0.024 moles of NaOH. Now, I have my NaOH, and I'm going to go here. We can completely ignore this right now because it's not important to us. Okay, we are going to go from here to here. That is a 2 to 2 or a 1 to 1 ratio, so we're going to leave it the same. So 0.024 moles of H2O, and it wants to know mass. So now we're going to use moles equal to mass over formula weight. X over 18 gives you 0.43 grams of H2O. All right, I'd pause the program. You probably need a periodic table and a polyatomic ion sheet for this one. You can see that they need you to write and balance an equation and then answer a question about it. All right, hopefully you gave this a try. It says a Tums tablet contains calcium carbonate, which will react with the 1.5 molar HCl that's found in your stomach. This hydrochloric acid is commonly called gastric juice. Here is the multi-million-dollar word equation. Calcium carbonate, okay, so we're going to write this. Calcium is a +2, carbonate's a -2. So in order to write that neutrally, we're going to be CaCO3. That is a solid, correct? Reacts with gastric juice, that they just said hydrochloric acid is gastric juice, which is HCl. And it's going to form calcium chloride. Calcium is a +2. Sorry. Chlorine is a -1. So in order to write this neutrally, we need to write it CaCl2. It also makes carbon dioxide, which you should know is CO2, and water, which is H2O. Now, before you do anything, you want to make sure you balance the equation. I see one calcium, one carbon, one carbon, but then I see 2 hydrogens here, so I got to balance that. Now I see 2 chlorines, I'm all balanced. Now the question was, we have solid this, and we also have a 0.5 molar hydrochloric acid solution. So it says, what is the maximum value of gastric juice, it's 1.5 molar, that would react with a single 0.5 gram extra strength Tums tablet? So if you think you can do it from now, pause the program, let's give it a try. The only thing I can find moles of is CaCO3. So I'm going to find moles of CaCO3 is equal to my mass of CaCO3 over 40 plus 12 plus 16 times 4, or 3, which is 100. You divide that, you get 0.005 moles, okay, of your CaCO3. I want to go from this to here, from my CaCO, how much of that, this is my question, I'm sorry, volume. Okay. Now I know that is a 1 to 2, so I'm going to double this reaction, or my number of moles, to get 0.01 moles of HCl. And now it wants to know the volume, and I have the molarity, so is equal to 0.5 times my volume. To get volume by itself, divide this by 1.5, divide this by 1.5. And we get the number that comes out of your calculator is always in liters, or we can move the decimal 1, 2, 3, and say it will react with 6.67 milliliters of hydrochloric acid in your stomach. All right, the last question. Let's have you pause the program. Ooh, giving away answers here. Try to read the question and balance the equation. All right, so to go through and balance these, we're going to want a 2, obviously, and a 2. And then in the second equation, all we need is a 2. It says, consider the following chemical reactions. The student performs the first reaction using 0.72 grams of pure magnesium. So I have 0.72 grams of pure magnesium. This reaction occurs in 100% yield. The student immediately takes the MgO and performs a second reaction. So let's figure out how much we're going to make in the first reaction. I have grams, so I'm going to take my grams and divide by the formula weight of just magnesium. When you do that, you're going to get 0.03 moles of magnesium. Now it says 100% completion. So how much of this are we going to make? It is a 2 to 2, so I'm going to keep the moles the same. Now the question here is, some people can say, hey, okay, then I'm going to go X, and I'm going to go 16 plus 24. We don't need to do this step because it says you are going to take this and immediately perform the second reaction. So I'm just going to take this number and I'm going to bring it down here. Now it's already in moles because that's how we start any Stoich problem. So I have 0.03 moles of MgO. And the question, second half of the question here says, what volume of 0.5 molar HCl is needed to react with all of that MgO? So I have 0.5 molar HCl. I want to know the volume of this. So this is a what to what ratio? 1 to 2. So I'm going to double that. So I'm looking at, I need 0.06 moles of HCl. I know the molarity is 0.5. What is my volume? Divide this by 0.5, get V by itself, divide this by 0.5. And you're looking at, your calculator says 0.12. What unit is that? That's going to be liters. Okay, and then, or you can move the decimal to say 120 milliliters. So hopefully that helps a lot. And if you have any questions, bring them on in class.